Inductor questions. At a given instant, the current and self-induced EMF in an inductor are directed as shown. Is the current increasing or decreasing? Well, let's think about it this way. If the current was increasing, we would have that the current flowing out from there is going to be adding to that of the EMF, which would then produce more current flowing through. This means that we're ending up with a greater amount of current through an inductor. But this sounds like free energy. So therefore, the current must be decreasing. As the EMF is in the same direction as the current, then as the voltage is increasing, the current is decreasing. We can't have free energy. Part B. The induced EMF is 17 volts, and the rate of change of current is 25 kiloamps per second. What is the inductance? Well, our equation gives us that the EMF is equal to minus L, our change in current over a change in time. Rearranging this gives our inductance is equal to minus our EMF, our change in time over a change in current. In any situation, you are unable to have a negative inductance. That would be like saying that this inductor is going to be able to provide free energy. Therefore, we don't take into consideration the negative. So now we can just put in our numbers. So we're putting in that 17 volts times by 1 over our change in current, 25 times 10 to the 3, which gives us 6.8 times 10 to the negative 4 Henry. And that is our inductance. A 12 Henry inductor carries a steady current of 2 amps. How can a 60 volt self-induced EMF be made to appear in the inductor? Well, if we look at our equation for inductor, we have that the EMF is equal to minus L, the inductance, and our change in current. Well, in this situation, having a steady current through is not what we're actually after. We're after a EMF of 60 volts. So therefore, our current is actually going to have to change in time. So, rearranging our equation gives that our EMF divided by our inductance is going to be equal to our change in current over a change in time. Notice again, I did not use the negative, as having a negative rate of current change is not possible. Now we can just put in our numbers. So we are after a 60 volt EMF over our inductance of 12 Henry gives us 5 amps per second as a change.